statistics end of design. So we'll talk about Tufte's principles and so on a little bit in a future lecture. But today I picked a chart that I like quite a lot. So here's a handout for you guys. Just move this back. Okay, so this chart shows the causes of untimely death in global health. And so this is, I picked this also because Bill Gates called it his graph of the year. I love this graph because it shows that while the number of people dying from communicable diseases is still far too high, those numbers continue to come down. But there remains much to do to cut down the death in that yellow block even more dramatically. We have the solutions, but we need to keep up the support where they're being deployed. So take a look at this chart and think about it for a couple of minutes. And there's a couple of questions that I put on the back side of this sheet. Think about those questions, take a couple of notes, and then we'll start the discussion in 3 or 4 minutes. Okay, so the first question that I always like to ask myself about such a chart is like, what is the data that we see here? So what's the data that is encoded here?
Causes of untimely death.
Exactly. And so what does it mean specifically?
I'm looking at the change, not the absolute value.
Only at the change?
Well, no, the size of the blocks is the actual number, but the coloring is...
Okay, so yes, we have 2 different data points, right? We have the proportion, like how important of a cause is this given every untimely death, and also we have the cause of the change encoded. And so, like, what are the visual variables, like the channels that are used, like for example, size, color, position, and so on, that are used to encode the data points here?
So you have the value of color, how light it is, or how saturated it is.
Exactly. What does that encode?
That encodes the increase or decrease annually.
Okay, yes. And so, do you think this is a good way of encoding that?
It's not necessarily visible on first sight. You definitely have to read.
Yeah. So, one minor thing about the color that you could change that would make it more readable. Any ideas? Like, assuming everything else stays the same, what could you change to make this more accessible? Take a look at the data. There's like increase and decrease. Like it's from -3% to +3%. Can you tell where 0 is? Yeah, so that's really hard to tell, for example. Like if you don't read the legend and can compare exactly which color means what, you don't have a good intuition of what is actually going down and what is going up. Okay, so what is the other, like we also mentioned that the proportion of how many deaths occur is encoded. What is used for this encoding? Exactly, so like precisely what kind of size? Is it volume or area. Size or area? Yes, correct, it's area. And so, could you, like, anybody have an idea, like, is this area that you see here, is it proportional to the pixels on the screen?
No.
Because?
Well, it is orthogonal, so I don't know if it actually is or not. If it was a perspective view, I could argue that it's not, but.
Well, it's still not. It's not like whenever you do this 3D transition and the tilting, you don't preserve area like pixels on the screen exactly to what the data is. So like we have the 3D tilt effect here. Why do you think the designer of this visualization picked this 3D tilt effect?
He added the broad categories on the sides.
Yes, that's a good point.
I think part of it was to make it look catchy because this is supposed to be in the Washington Post for general readers who don't necessarily care.
I think that's the main reason, yes, I agree. So this is really about making this look catchy. And so yeah, there is a point about making stuff look catchy, right? If you want to publish in a newspaper and you want to get clicks and you want to get people's attention, you might actually get more attention if you have a chart like this. So, do you guys like this visualization? Any personal opinions?
One thing I don't like is the anonymous data that you have. You have these encoded areas that, I don't know if they are representing necessarily any diseases or they're just there to make sure the area is equal. Yeah, like that.
These ones? Yeah, so what happens here?
Like, it's just confusing. Is that actual data or is that just there to fill up the...
Yeah, so my guess would be that it's too small to put a label in. Yeah?
So my only complaint is, I couldn't really see it on the page, and I was like, oh, it's just because it's printed. So I went to the website, and it's not much better on the website. So I wish that perhaps the guy would have done something to make the smaller things pop out more, maybe make it interactive or something like that.
Yes, interactivity would be a good approach here. And then, like, any other opinions? Do you like this chart? Anybody want to say something? Yeah?
I don't like this chart because it doesn't say what data it represents. Like it says cost of untimely death, but it doesn't define what metric is used to see all this. It's like, only if you read that graphic to realize that it's life years lost. And that metric is not also defined clearly as in what you define as life years lost. Is it like average expectancy or?
Well, I totally get your point about this being not very clear about what it represents. I think life years lost, I would assume that it is relative to average life expectancy in the various countries.
Yeah, but it doesn't say that what percentages it is representing. It just gives you random numbers, but it doesn't say what it represents.
Yes, that's true. Okay, and so like, yeah?
So it's unfair, like you said, with the pixels not matching the area.
Yeah.
It's sort of highlighting like what the author wants to highlight.
Yes, so do you think that Bill Gates chose this chart because it is like the best visual encoding that you could think about as his favorite chart of the year 2013? Why did he pick it? Yeah, so because he cares about the issues, right? He doesn't care too much about the visual encoding. So how could you redesign this? Any suggestions, any ideas? What could we do different?
For each of the sub areas go to a two-color system instead of a single color, so you know where the 0 point is.
That would be definitely an improvement. And so I actually, like, somebody on the internet has done a redesign of this chart, and I'm going to show this to you. Any other comments before I show you the redesign?
Take it to 2 dimensions and also orient all the words in the same direction.
That is a good approach, and you will be surprised how the redesign looks. So the redesign is like a boring bar chart, as you would see maybe in a government report. But there's a couple of interesting choices made here. So first, like, he had 3 different colors. Like, this is by Stephen View, a blogger, Perceptual Edge. He runs a visualization consultancy, so you can go to his blog. He's like a very, let's say, he likes to critique a lot, but his blogs are definitely worth reading, and he also had a couple of books. And so you should take a look at this, and especially at this particular post. And so what he did here is essentially reorient this chart and use bar charts for that. So the first chart here, and it might be a little hard to see for you, but this is years of life lost per 100,000. Then he has an explicit column with change in years of life lost. And that is a very, very effective technique. If you want to visualize change or something, instead of visualizing A and B, visualize explicitly the difference. And so that's what he's doing here. And so we can immediately spot, okay, for neonatal disorders, this has dropped quite a bit. But here, for injuries and other self-harm, this has actually increased quite a bit. So this is an interesting fluctuation. I couldn't really explain that. And he's also very explicit in this change in years of life lost in this particular period. And then he also shows us the death per 100,000. And so what we can see here is that the relationships of the death per 100,000 to years of life lost. So we can see that cancer is like a very frequent cause of death by looking here. But also, therefore, it's not very surprising that there's a lot of lives lost. So if we look at another disease, like neonatal disorders, there's like very few of those, but of course, since this mainly affects babies, the years life lost is pretty high. So these are the kinds of insights that you can learn from this chart efficiently. And he also uses these color codings here for communicable diseases, non-communicable diseases, and injuries. And so here, the communicable diseases are the ones that are easier to treat, presumably, than the other classes. So, any questions or comments about this? Yeah?
I guess, like, if I open this into a magazine, like, I might not stay on the page just because it's like, the colors are so bland. I mean, like, I see how it, like, communicates information more clearly.
Yeah.
If I was, like, writing a report on this, like, I would appreciate this visualization more. But if I was just, like, a casual reader.
Yeah, and so you're making a great point. So I think that the best visualizations are those that are both efficient and catchy for news media. And so, like, how do you make this one catchy, right? There has been studies in visualization that, for example, if you put a human face somewhere here, people will draw attention if you, like, juxtapose this with a picture. So you could use some separate design element to make it catchy. But yeah, I get the point, and it is like this kind of fine line that we have to walk. But, like, I wouldn't personally sacrifice accuracy for effect. I think we should strive to get a good effect and be accurate about it. Yep.
There's one more thing I really don't like about this or about the other one, and that's this reliance on percent change, which I guess is more of a critique of how people just get report data in general, because percentages mean nothing. I mean, 2% of 2% or 20% of 2% is pretty minimal. So you're getting too much emphasis on a percent change of a smaller number.
Well, that's true. But you also have the other data, right? Okay, you could show the data in years of life lost in 2005 too.
I mean, when you evaluate effectiveness of models, you look at misfit and residuals much more than you would look at percent error.
Yes, that's true. I think it is a valid critique. I think it's also not bad to show the percent change. I would agree that if you want to like really dig into the data, you should also show the raw data. But here it kind of like makes you look, and if you see like one of the major like meningitis and hepatitis, for example, the big decrease, this is a significant chunk of data, and there is also a significant decrease that you can see here. But you could also show the absolute numbers, like the difference in absolute numbers per year, for example. Not in percent. Okay, any other comments?
Do the redesigners, did they discuss any reason why they got rid of the, or changed the way that they, the groupings? Because I thought that was the one really effective part of the original.
Well, yes,
that it was
so
all grouped
like,
very clearly, and you could see the proportion.
this is a question of your task, right? What do you want to show? And so the designer of the original chart has chosen it's more important to group by the big categories, and the redesigner here has chosen it's more important to sort based on the absolute years of life lost in 2010. So that's a choice of your task, and in an interactive technique we can do both. We can actually say, okay, sort by cause of lost life, or sort by years of life lost. So that would be possible in an interactive chart. Yeah?
I think what we're really talking about is like, what's the intent of the graph, right? Because it seems like if you were like reading some scientific report on causes of death, right? You'd want this one. But if you're, like we said, a casual reader who just wanted to have some talking point, you'd be like, oh, it looks like most kids die of malaria. That's going to give you a 10-second look, and you instantly know that data. Or this, you have to parse it for 5 minutes to understand what the graph is saying, and then you put it right.
So you're actually arguing that the space-filling layout is easier to understand by a novice than this chart?
Right. For a casual reader that doesn't care about detail, they care about generalities, so they can, because no one's going to be able to say, if you're a casual reader, they're not going to say like, oh, cancer decreased by 10.3% over, they're going to be like, cancer is decreasing.
Yeah, okay.
This is the real problem.
I get your point, but also like think about especially this mistake that they made in the original chart with not having a neutral color for 0, like for no change.
That's true.
So like there, like if I would definitely buy your point if we had a more explicit representation of negative versus positive change. So then I would definitely see something here. But in this case, like compared these two charts, I would actually argue that this is the main point of the chart, how it has changed in the last 5 years. And so like as always, like in visualization, it depends on the questions that you want to emphasize and the tasks that you want to solve. Okay, any other comments or questions? Great, so with that, we'll move on to a little bit more technical section. Okay, so you can actually follow along this again if you go to here on the website to tutorials, and then there will be this interactive JavaScript introduction. Okay, and so what I would really suggest to you is that if you want to follow along here, is that you open up the console, and so we will be essentially today not really using the DOM much, but we will be using the console quite a bit. So we can simply switch to the console here, and also like if you want to ever clear the output of the console to see what is going on, simply execute the clear function. Let's just clear and then brackets. Then the console is cleared, and then you can find exactly where you are again. So this lecture is about, the rest of this lecture is about JavaScript, and mainly of how is like JavaScript a programming language and how is it different from other languages that you might know. Okay, so we've done some static HTML and SVG previously, and now like in this lecture we will learn the fundamentals of how to use JavaScript. In the next lecture we will then learn how can we manipulate the DOM so that we can create a dynamic website. And so you want to be able to, like for example in your homeworks, right now you have manually encoded every position of a bar chart, and in the future we of course want to be able to say, okay, here is an array with the data and map that to the length of these line charts, or the length of these bar charts, or the position of these line charts. And so JavaScript is like the most important programming language of the web. By now it has essentially surpassed anything like Flash. Flash used to be really popular 5 or 10 years ago, and now barely anybody uses Flash for new projects anymore. And JavaScript is mostly used on the client side, so it's an interpreted language. It's not compiled. It's not translated into machine code or in bytecode. Other languages like Java and Python would be like popular complements on the server. JavaScript, however, you can also use it on the server nowadays with, for example, Node.js, but in this class we will be focusing on the client-side aspect of JavaScript. And JavaScript can be used with a couple of different programming paradigms. It can be used in an imperative, procedural paradigm, in an object-oriented paradigm, and also in functional programming styles. And we'll actually be using a mix of all of those throughout the class. JavaScript is a dynamically typed language. That means that we don't have to explicitly specify which types the variables are, which is, like, I used to work a lot in Java before I moved into JavaScript, and that was really hard for me to have this super flexible way of assigning variables. And then also JavaScript is a little bit weird in terms of how it does inheritance and essentially object-oriented programming. It doesn't have a class. It is like a prototypical inheritance. So there is no class definition, but if you, for example, want to inherit information from another object, you really inherit directly from that object. And so I'll have an example at the end of the lecture about this. So this was kind of like, if you know everything about programming languages and just wanted to understand where JavaScript falls in on the spectrum, that kind of was the gist for that. So let's do something very basic. So this whole course, like the interactive parts, we zoom out a little bit more. Here is designed so that these consoles are interactively executable. So here I'm just writing to the console, and writing to the console is very helpful if you, for example, want to debug your code. So here I'm simply saying console.log, I'm logging a message, and actually this should be hello world, of course. And so as soon as I've changed something, so after a couple of seconds, this thing here will re-execute, and you will see the output of the cell here in the console down here. So if you want to play with this, change something here, you'll see the output here. And then again, you can clear if you just want to get rid of it. Okay, so pretty simple. We are outputting a string here, we are outputting a number here, and we are outputting a different number here. Okay, and so there's we see P and an approximation of P and the string. As any other programming language, it has variables. So here we store an integer as a number, and JavaScript doesn't really distinguish between their representation of floating point numbers and integers. Internally it does, but you basically don't usually need to worry about this. Here it's a string, so B in this case is assigned a string with the number 1. Here we have an array, like C, with lots of strings in it. Here we have an array with numbers in it. And then we have an array with mixed data types. And that's something that you can do in JavaScript, but you shouldn't. Yes?
Why do you only have semicolons on some of the lines?
Because it is a style question in JavaScript, and I wasn't careful. That's the answer. So yes, you can do semicolons, you cannot, you don't have to do them. Sometimes it makes it more explicit when you turn in a statement, especially if you want to do multi-line. Typically, there's I guess there's the internet is split on whether you should use them or not. And I'm trying to use them usually, but since it doesn't throw an error, it's easy to miss them. But good question, yes. And so here you have an array of mixed data types. And a 1, 2, 3 string, and an array with only one element of 4, and that isn't really great practice, so that's something that you usually shouldn't be doing. Boolean data types are also available here. We're assigning false to F, this is the literal for the false Boolean data type, and then we can check the type of a specific variable. So here, I'm checking, what is the first thing that I check? So that's why we need to clear. So like the first, if we run the type of operator, we get back that it's a Boolean, and then I'm running this again here. I can redefine the same variable to a number, which is, for example, that wouldn't be possible in a statically typed language. And then I can check what is f now, and now it is actually a number. There is a distinction between local and global variables. Like I've used up to this point only global variables, so they are kind of attached to the global context, which is the window. We can also define these local variables. That is, like in this case, it doesn't make a difference because we're still in the global context, but if we define a variable like this within a function, it will actually be only like scope, in terms of scope, it will only be accessible within that function. And that is, of course, good programming style because you don't want to pollute your namespace. Okay, the var keyword essentially distinguishes the local variable from the global variable. And so one tricky thing about JavaScript is if I, for example, were to reassign this name variable at some other point, but I misspelled it, JavaScript wouldn't tell me anything, right? So here, instead of reassigning the variable, I have actually created a new variable. So that is a potential source of errors. And in this case, I have actually created a global variable, and I was just planning to reassign the variable. Okay, so like a general rule that applies to basically all programming languages: minimize your use of global variables, and never ever define global variables within a function. So if you need to define global variables, make it explicit at some central point and use them there, but don't do it like somehow backhandedly within the function. You can of course execute operations on these functions. So here we like an addition, a simple addition here. Then we have this increment operator, like add to the shorthand for adding. So this is of course equals to sum plus 1. Then like here we have increment by 1, decrement by 1. We have a division. We have the modulo operator that is essentially like a division by the number and then the rest assigned to it. We can also again like check at the data types here, the type of operator. We can assign the type of, the result of the type of operator, and then print that, and you'll find that this actually returns a string of type number. And so usually you shouldn't make these kind of like checking for a type and doing something depending on the type. That is not usually a good programming style. And so here we can do like string concatenation like we can do in Java. Okay, a little bit more about arrays. So here's a numerical array, like pretty straightforward. Here's an empty array. We can access it like as we would expect with the indices. This is like again, this is what we shouldn't do. This array of multiple data types, and so we can access like print the these elements of this array. That is totally valid. Again, so here we see this and then true as that we have access to from this array, and then we can ask for the length of an array by accessing this property, and we can also nest arrays, which is of course very useful, and if we want to work a lot with data. And yeah, obviously this is how we access a nested array. Arrays are different in JavaScript from, for example, in C or in Java. They are not really, they're actually more like lists than arrays, because typically in C you have to allocate a specific size of an array. In JavaScript you can simply treat them like lists. You can dynamically extend them. So here I'm pushing the number 3 to this numerical array, and then I'm pushing the number 4 again, and the push operation returns the length, the new length of the array. I can also pop from that array. I can run an index of operator. Yes?
So when you did nested bracket 1, bracket 0, were you saying I'm going to go to the 0, 1 position and then the 0th position within that first one? Is that why it popped up at number 3?
Yes, exactly. So I'm going to the arrays are indexed by like starting with 0, and so here by nested 1 I'm accessing the element, the second element at index 1, and then for this list, I'm accessing the first element at index 0, and that's why we get the output now of number 3. Any other questions? Okay. We can also, like, these arrays have built-in functions, and so like I've put links into the Mozilla Developer Network documentation of the main things here. For example, we can, like, the index of is a function, but we can also sort this. And so let's take a look at what the output here is. So we see 12, 15, 21, 3, 4. That isn't really what we expected here, probably, right? If we simply cold sort an array, we would expect it to sort it actually by, like, it's an array of numbers, and so we would expect it to do a numerical sort. But actually, JavaScript by default does a sort by text. So it actually looks at what is by ASCII character, what is the shortest, or the first element is like 1 first, and then 2. 1 first, and 5, 2, 3, 4. So if we want to actually sort this array based on numbers, we have to define a compare function, and that compare function is pretty simple. In this case, it's a minus b, so like that's the usual thing. If the compare function returns 0, it's considered equal. If it's -1, then the second parameter is smaller than the first one. If it's +1 or positive, then the first parameter is bigger than the second one. And so here we essentially, this is a compare function that we can pass into the sort function, and so it will use this function to sort this array, and now we can see here the numerically sorted array, and here it does what we would expect from it. So 3, 4, 12, 15, 21. This is how I would sort a numerical array. There's a couple of subtleties here that I will be talking about later. Okay, another interesting thing about JavaScript is that objects are essentially, like general objects are essentially the same as hash tables. So the attributes of an object can be accessed like a dictionary or a hash table. So here I'm defining an object with these curly brackets, and then I'm assigning key value pairs. So here we have key 1 is 3, key 2 is 4. And so there's two different ways of accessing those afterwards. It's like I can easily use the dot notation as for objects in many other languages, but I can also use this array notation and pass the key as a string here. And depending on, like, there's certain restrictions on like what you can use as like a symbol here. The string version here always works. And so what this does is actually, it's simply like every field in an object is directly accessible via these different notations. So there's no distinction between an object and the hash table or a dictionary. Yes?
So the array of push, will it actually discard the old array and do a new array, or?
What's the question?
So if I do a push on the existing array, will it discard the old array and create a new one?
No, it will actually do it in place. But I wouldn't, like, I'm pretty sure it will do it in place, but I'm not 100% sure. But I think it actually does. We can take a look. So push should be like, it doesn't copy it over. So, yeah, so here I'm not reassigning this. So that would mean that if I console log num array, yeah, so it is actually yes. Push. Yeah, so we see here we've added this 1999 to that array. So it doesn't copy it over and return a new array. It does it in place. And the same is true for pop. Okay. Then we can also define objects in this notation where we give everything as a string. So like here it's a string key, colon, and then another string. And this is basically what JSON looks like. So this is a JavaScript object notation. So like that's a convenient data format that we'll be using a lot. We can then, however, access it just as we would expect. So.
You're missing one.
yes. Value of string key 1 is 3. So there was a 1 missing here. But what would happen here if we had this value of string key and I've used it like this, then we would simply get an undefined here. Okay, and then we can also dynamically add new keys. So we can do this like that, like just say something dot new variable name and assign a value to it. So here, like we're seeing this dynamically added, I can add another one. And so I have dynamically added 2. And if I were to do this here, then I could look at the new key 2. So that's pretty simple. Any questions about objects and this like relationship to dictionaries? Okay. We have the standard control structures like if. We have the standard ways of interpreting what is a true and a false value with like any positive or negative number being true, any 0 being false. And then we have the standard operators to test for equality or bigger than or whatever. So here's an if, else if, else log statement. We have the ternary operator. So here if 4 modulo 2 is equal to 0, then do, like if this condition here is true, then do that, and if it's false, then do that. So like this is like an important shorthand operator that you will see if you read other people's code quite a bit. There is switch statements. The switch statements are based on strings. So we can switch on a string here. And so yeah, also pretty standard. Important for switch statement, as in other languages, is to do the break. If you don't do the break, it will continue for searching for it, and then eventually, if there's no other match, it will do the default. So if I were to remove this here, we should see both unlike C and default. Okay, loops. We have the basic C style loops with like index incrementers and so on. We have the basic while loops that also work like you would expect. So we have the Boolean condition here, and then we iterate over that, and then we can essentially continue until this condition is false, and then the loop terminates. The do-while loop is very similar, with the exception that you don't have to meet a condition first. It will go through it at least once. Yes?
So, are there no header files for this? Like, for example, console, is it important for some package?
No, there's no header files. There is JavaScript has a lot of stuff built in the language, but you can also use libraries, and you would include them, for example, with an explicit include statement. So we'll do this kind of like when we use libraries, for example, D3, we'll include that via the script tag in HTML. You can also include it directly from JavaScript. So there is no header files that you need to pre-include like in C. But everything that I'm doing here today is part of the standard language, not any libraries. So if you use then jQuery or Ordinary or something like that, you would have to include that. So another thing that is very common is iterating over the elements of an array. And there's a couple of different ways you could do that in JavaScript. There is the standard way of doing it with the regular for loop, where I would simply access, do something like this and check for the length and terminate at if I reach the length of the array, like the classical traditional for loop. It's more common in modern languages like Python or JavaScript to have these for each arrays. JavaScript, anything prior to ECMAScript 6, so the 2050 version of JavaScript doesn't support an explicit for each loop, but Array has implemented a for each function. So what you can do here is here I've defined an array with years, and here I'm calling on this array the for each function, and I'm passing an anonymous function to this function, and that does something. In this case, this anonymous function logs the element. And so here is the parameter that is the element of these arrays. And so you can see that we get this. yeah, array 1954, 1949, and so on. So like this is how we can do that. And I'll talk a little bit more about this anonymous function syntax here later. And then we can also now do in ECMAScript 6 a for each loop. It's not in, but it's off. So it's for year of years. And then you can log the year here. And that only works in newer browsers. So ECMAScript 6 is this new standard, and it's not quite like browser compatible to really use it. You quite often have to transpile it. It is not possible to transpile it, so we will use like the essentially pre-ECMAScript 6 version in this class, but next year I'll probably be teaching with ECMAScript 6. You can also take a look at ECMAScript 6 features and how they're compatible with various browsers. So you can see that like ECMAScript 6 is 97% compatible with the latest Chromes, but it's not really very compatible with, for example, Internet Explorer 11. So there's like only 11% compatibility. Yes?
Can we use ECMAScript 6?
Yes.
You already know.
If I'm not going to teach it, but if you know and like it, you can use it. But should make sure that you should only use the features that work on our reference browser in Chrome. And that shouldn't be a problem because it basically supports everything that you want to do, but you should think about that.
So it just needs to work in Chrome?
In the latest version of Chrome, yes. That's our, like for all of our homeworks and projects, there's our reference implementation. We're not going to take, like, we're not going to think too much about browser compatibility in this class. If it works in the latest version of Chrome, it's correct. But ECMAScript 6 has a couple of cool new features that will make JavaScript more pleasant to write and more reliable. And so you can do a for loop with the ins key here for in years. However, what is like bizarre is here I'm actually like printing the year, and what it does is it simply prints the index of the objects in the object. So if you look at this years array, it is actually implemented like the object. So we have like the index, like 0 is 1954, 1 is 1949, and so on. So what it returns, this in statement here, is not the year, but it's actually the index of the years. And so you might think, okay, well, I can work with that, but in reality, there's no guarantee about the order of these things. Like how that comes out is completely dependent on the implementation of the browser. So the simple statement is, if you assume any order, or you shouldn't basically use this for in statement, but you should rather use the for each function that comes with an array, or you should use the ECMAScript 6 version with the off keyword here. Any questions about this? Great, so functions is something that is also quite interesting in JavaScript. So this is like our standard definition of a function. We have the function keyword, and we name the function, and we put in a parameter. And so here we're doing something. If it's smaller than 10, we simply return the parameter, and if it's bigger than 10, we return like the parameter squared. So we can see what that returns here. So like the function for 30 returns 900, and the function for -5 returns -5. So that is kind of what we assume. JavaScript, however, tries to be like as forgiving as possible with sometimes unintended consequences. So here we start with a call to the function with a string. So like here I'm calling the same function with a string that simply contains a number. In this case, it's a string that contains the number 50. And JavaScript will simply assume that you meant the number 50, not the string 50, and will do that for you. So here is the function for a string that can be converted to a number. 50 would be 2,500. No warning, no whatsoever. It simply does it. And then if we put in any other string, we also don't get a warning. We simply, like JavaScript tries to cast it and finds, okay, that's not a number, so the operation will simply return not a number here. And then we can also do really crazy stuff like put in more parameters than our function actually accepts. And it will just like take the ones that it can use and ignore the rest. So here, this worked for the 30. And the who string here is not used at all. It's just dropped silently. So that can lead to some interesting bugs. And then you can also call this function without any parameters. And it will still execute, and it will still give you, in this case, it will just assume that the parameter that you didn't pass in was meant to be undefined. There will be no warning, and it will simply assume it's undefined and will output not a number in this case. So these things are a little bit different in ECMAScript 6 if you're in the strict mode, but I'm not going to talk too much about this. So no runtime errors, and that's like a theme in JavaScript. There's basically very, very little runtime errors. Like there's syntax errors, but otherwise there's a lot of things that in other programming languages would result into runtime errors. Scope in JavaScript is largely as you would hope for. Like here we were defining these local variables by using the var keyword. And then here I'm actually doing something that I really shouldn't do. I'm defining a global variable within a function. And so this is what I mentioned earlier. Z is now actually accessible outside of the function. It's part of the global scope. So like if I, like the return value here, this is pretty predictable. The return value here is 80. But if I were to call to, if I were to access x or y here, that wouldn't work. So that gives us a reference error. It's not defined. However, I can, without any problems, access z here. So this works, but it's a bad idea, and z is accessible. I've defined it within the function, and still accessible. It's a global namespace, and that's like a common bug of polluting namespaces. In JavaScript, there's also another way of defining functions. So like here, this is the way that you know from, for example, Java or C. And here is another way of defining a function. I'm creating an anonymous function here, and then assigning it to a variable function. And that is kind of really neat if you think about it, because now you can pass functions as parameters, and you can also return functions. So you get into this functional programming paradigm. And so this works exactly as you would expect. There's a couple of subtle differences, but usually you don't notice them. So like we get the same output. And then we can also reassign these functions. So we can take this function name and put in another function that does something completely different. So this is like just like a variable. That is maybe a good idea, but rarely so. Okay, and so this idea of functions being variables is something that is really, really deep in JavaScript, and also especially in D3. So here's another example for that. We have an array of numbers, 13, 16, 19, 22, and then I'm using the map function, and the map function essentially takes a function as a parameter and applies it to every element, and then returns a new array that is a result of that. And so I am not actually defining this function somewhere else. I'm saying simply, this is my function d, and it multiplies d by 2. Yep?
How would it work out if you're passing a function that's actually modifying your my numbers? So like, you're adding an element to my numbers, or you're popping, you're pushing.
That's a good question. That is something that you would have to simply trace out what the logic would do. But you could do that, yeah, and it wouldn't like be very sane, but it's possible. But yeah, this is like a common problem. If you iterate or if you apply something to a data structure while you're changing the data structure, it can, like if you really think about it, it can work out. But if it also calls for trouble.
Right.
So yeah, this function here isn't ever, like, it's never given a name. That's like what's called an anonymous function or a lambda abstraction. Like if you ever hear the word, Python, for example, has these lambda functions that work exactly the same way. And this is something that is extremely very common in D3. So like many times you will use this paradigm. You essentially have a function here, and then you want to pass in a function that does something to the data elements. And so you create this function, this anonymous function, pass in the data elements. So this would be like first 13, then 16, then 19, then 22. And then you do something with it, the data element here, and then return it. And that's how lots of the D3 aspects also work. So any questions about this?
I had just a comment about the scope, variable scope. I just wanted to mention that because if you're used to Java or C, it can be really confusing if you don't realize that when you declare a variable with var, it's function scoped, not block scoped.
Yes.
So if you declare it like inside of a for loop or inside of an if block, the whole function can access it even outside of that for loop.
That's true. That is one of the interesting, confusing bits about JavaScript. Thanks for the addition. Any other comments or questions? Okay. So then let's take a look at how we could do some object-oriented JavaScript. Here we have a function, create object. And I'm assigning it like a variable result, and within the result I'm assigning more like variables here. That would be get here would be a function, like this. Any variable can be a function, is here used to the max here. So get is like simply a getter function that returns the content that was passed in, set sets the content, and then twice multiplies it. And it's like, again, these functions that are assigned to these variable names. And so this is essentially how we can build object-oriented programming in JavaScript. And so here's an example of how to use this. So we first create the object something, and then we ask for to retrieve the value, and so we get the something element out of here, and so this uses the getter function here and returns it, and then we try to multiply it with 2, and of course that doesn't do something here because we cannot multiply a string with 2, so we get not the number back. It tries to implicitly cast it. Again, no runtime error. Then we can set another value here with using this accessor function. In this case 20, and then in this case, of course, we can access it via the getter again, and we can also multiply it by 2 in this case, or like call the twice function, which does run the multiplication by 2 for us. So that's like how you can do an object-oriented paradigm. One of the many different ways of how you can do an object-oriented paradigm in JavaScript.
Quick question.
Sure.
Is NaN a type or is it just a string that's returned to the console? Not a number.
NaN is not a number. It's not a string.
It's just a string.
No,
it's actually typed.
Yes, but we can check. Twice. Return type content.
It's type of, right?
Yes. Sorry, my Python. No. What was it? Type?
Lowercase.
Yes. So yeah, it's a number. Not a number is a number. Is update as have number. Okay. So we have objects. How can we do inheritance? Like we don't have. It's not as easy or not as obvious to how to do inheritance in JavaScript. And so what JavaScript does, it has a prototype chain. So each object can have another object that is considered to be its prototype. And so there's an explicit reference in each JavaScript object to its prototype object. And that can be another object or it can be null. So if I were to have, for example, some like definition, well, let's just go with the example here. That's the simple case. So we have a base, and then we have a derived object. In this case, we have v1, v2, and here we redefine v1, v3, and v4. So there's like v2 is unique, v3 and v4 is unique, v1 is defined twice. So if we just look at this before we do anything else, we can see base v1 is 1, derived v1 is 5. So like this is what we would expect. They're just these names, of course, they don't have any meaning at this point, but this is like we exist these specific members of this object. And then we can say object.setPrototype of derived base. So set the prototype of the derived class to be the base class. And then we suddenly see that if we call derived v1, we get the 5 here, but we can now also in derived access v2 down here. So this wasn't defined in the derived object, but now that we have set the prototype, it is actually defined. So how that works is that it will simply look at the prototype hierarchy, look at the namespace of the first, like of the top level object. If this function or variable is defined there, then it will return the result of it. If not, it will go back one step in the prototype hierarchy, look what is defined there, and then return that if that exists, and so on, until it reaches a null reference, and there's no more, like, until you have reached the end of the prototype chain. And so what that means is that you can also go in and take, for example, the array object and override the map function. You can actually say, okay, I want to change the map function of the array, and then for the rest of the execution, it will actually be have a different implication. Okay.
It's only, I'm sorry, that's only for the array that you build. That will override the
yes.
the reserved classes.
Yes.
I guess.
Unless you override it in the array prototype.
Yes. If you go into the array prototype, you can also override it. Then it will apply to all of them. And so D3 actually in the implementation of the D3, it did some stuff like this, but I think they changed that in version 4.
Does JavaScript reserve any? I mean, is anything off limits, or will it allow you?
Everything basically is fair game in JavaScript, especially in the older. Like it is kind of like it's a great language, but it can also be pretty messy. And so there's like this book, like JavaScript, the good parts, which is really thin. But the good parts about it are pretty nice to work with. It's not let's say it's not really wasn't written to write this big software project with it. It was meant to be like make your text blink on your website originally, and now people have changed that quite like have rely on JavaScript so much that that it's like we're building things like word processors completely from scratch in JavaScript. And there, these standardization efforts with the different ECMAScript versions, they go into making it a more structured and more controlled programming language. There's also like TypeScript, for example, which is a script language on top of JavaScript that you can compile into JavaScript. That's a Microsoft implementation, and that's, for example, what we personally, what my research projects we use for data-heavy aspect of some client software. And so we write the data-heavy part where we really want to have type safety in TypeScript, compile it to JavaScript, and write like the explicit visualization code in JavaScript. So, and yeah, there's like many different ways of how you can generate JavaScript code out of various different dialects and languages. So it's a little bit of a Wild West with these web languages right now. So, and then the last couple of minutes I wanted to talk about the variable this. And this is like, usually that means that refers to the object that you're currently interacting with. In JavaScript, however, this is a little bit weird. This refers to the object that is calling, and not to the object that you're applying it within. So here's an example for that. This is like an object, and here we have this, we define x to be 3, and then we define a getter function where we, like, here I'm just logging some information to see what this does. Okay, so let's take a look at this. Here, this is defined to be the object, so as we would expect. This and this is really, by the way, pretty nice. You essentially have this inspector. If you print a variable like this, you can in the console you can look at each of the data types, into each object. You can really drill down like in a debugger. And so you see that get is defined as the function. Is exactly what we did here, and then x is assigned to 3, and so this is exactly what you would expect. And so this .x is defined and returns what we would expect. So let's do something else. Here, we can by using as I said before, we can take a function and assign it to another variable. And so here I'm taking this get function from the object and assigning it to another variable, in this case t. And then let's see what this does. So here, this in here for the call get, this is generated by that code here, like by the t. We call that get function. And so here, this is suddenly not anymore the object itself, but it is the window object, like this global object. So that means the context of the call here is the window object, like the global context. And so this is what this refers to in that case. And so that's not what we really are expecting, and that's also a common error source in JavaScript. So this I think is just the same thing twice, yeah. So what happens here is when t is called, this is not defined as the object, but it's this other window object that contains all of the browser-specific things that we have in here. Okay, so any questions about this or any other object aspects or any other general JavaScript questions? Okay, well, if not, that's my script for today, and next week we'll be talking about how do we manipulate the DOM, how do we actually add elements to websites, and how do we use T3 for the first time.